Good day everyone, I'm Leslie May Bognut and I will be presenting to you exercise 13. In exercises 5 to 24, find the inverse of the matrix if it exists. The given matrix, which I will label as matrix A, consists of 1, 1, 2, 3, 1, 0, negative 2, 0, 3. We adjoin the identity matrix to form a doubly augmented matrix consisting A with 1, 1, 2, 3, 1, 0, negative 2, 0, and 3. And I as separated by a dotted line having 1, 0, 0, 0, 1, 0, 0, 0, 1. So first, we need to row reduce A to I using the elementary row operations on the entire matrix. The first thing we need to do is to make the first element of row 2 0 by following the notation row 2 plus negative 3 times row 1 is equal to the new row 2. So, 3 plus negative 3 times 1 equals 0. 1 plus negative 3 times 1 equals negative 2. 0 plus negative 3 times 2 equals negative 6. 0 plus negative 3 times 1 equals negative 3. 1 plus negative 3 times 0 equals 1. And 0 plus negative 3 times 0 equals 0. Next is to make the first element of row 3 0 by following the notation row 3 plus 2 times row 1 equals the new row 3. And so, negative 2 plus 2 times 1 equals 0. 0 plus 2 times 1 equals 2. 3 plus 2 times 2 equals 7. 0 plus 2 times 1 equals 2. 0 plus 2 times 0 equals 0. And 1 plus 2 times 0 equals 1. After which, we now make the second element of row 2, 1, to have a leading entry by following the notation negative 1 half times row 2 is equal to the new row 2. And so, negative 1 half times 0 equals 0, negative 1 half times negative 2 equals 1, negative 1 half times negative 6 equals 3, negative 1 half times negative 3 is equal to 3 halves, negative 1 half times 1 is equal to negative 1 half, and negative 1 half times 0 equals 0. Next, we make the second element of row 3 0 by following the notation row 3 plus negative 2 times row 2 is equal to the new row 3. And so, 0 plus negative 2 times 0 equals 0, 2 plus negative 2 times 1 equals 0, 7 plus negative 2 times 3 equals 1, 2 plus negative 2 times 3 halves equals negative 1, 0 plus negative 2 times negative 1 half equals 1, and 1 plus negative 2 times 0 equals 1. And next, we make the third element of row 2 0 by following the notation row 2 plus negative 3 times row 3 is equal to the new row 2. And so 0 plus negative 3 times 0 equals 0, 1 plus negative 3 times 0 equals 1, 3 plus negative 3 times 1 equals 0, 3 halves plus negative 3 times negative 1 equals 9 halves, negative 1 half plus negative 3 times 1 equals negative 7 halves, and 0 plus negative 3 times 1 equals negative 3. We now proceed to making the second element of row 1 0 by following the notation row 1 plus negative 1 times row 2, which is equal to the new row 1. And so, 1 plus negative 1 times 0 equals 1, 1 plus negative 1 times 1 equals 0, 2 plus negative 1 times 0 equals 2, 1 plus negative 1 times 9 halves equals negative 7 halves, 0 plus negative 1 times negative 7 halves is equal to 7 halves, and 0 plus negative 1 times negative 3 equals 3. And finally, we now make the third element of row 1 0 by following the notation row 1 plus negative 2 times row 3 is equal to the new row 1. And so, 1 plus negative 2 times 0 equals 1, 0 plus negative 2 times 0 equals 0, 2 plus negative 2 times 1 equals 0, negative 7 halves plus negative 2 times negative 1 equals negative 3 halves, 7 halves plus negative 2 times 1 equals 3 halves, and 3 plus negative 2 times 1 equals 1. Based from our solution, the matrix A is invertible and its inverse is A raised to negative 1 is equal to negative 3 halves, 3 halves, 1, 9 halves, negative 7 halves, negative 3, negative 1, 1, and 1. And now, we do the checking part to know if our solution is correct. A times a raised to negative 1 shall be equal to I. And so we multiply them. For matrix A, we have 1, 1, 2, 3, 1, 0, negative 2, 0, 3. And for A raised to negative 1, we have negative 3 halves, 1, 9 halves, negative 7 halves, negative 3, negative 1, 1, and 1. By multiplying, we have 1 times negative 3 halves plus 1 times 9 halves plus 2 times negative 1 is equal to 1. Then 1 times 3 halves plus 1 times negative 7 halves plus 2 times 1 equals 0. And then 1 times 1 plus 1 times negative 3 plus 2 times 1 equals 0. Next is the second row. So 3 times negative 3 halves plus 1 times 9 halves plus 0 times negative 1 is equal to 0. 3 times 3 halves plus 1 times negative 7 halves plus 0 times 1 equals 1. And 3 times 1 plus 1 times negative 3 plus 0 times 1 equals 0. And lastly, for the third row, we have negative 2 times negative 3 halves plus 0 times 9 halves plus 3 times negative 1 is equal to 0. Negative 2 times 3 halves plus 0 times negative 7 halves plus 3 times 1 equals 0. And negative 2 times 1 plus 0 times negative 3 plus 3 times 1 is equal to 1. And as we can see, we have obtained 1, 0, 0, 0, 1, 0, 0, 0, 1, which is the identity matrix. Therefore, our solution for this matrix is correct. That's all for exercise 13. Good day and God bless.